Hello, let's talk about a programming assignment for Chapter 5. You have to complete number 13, page 151 on Chapter 5 in your textbook. So I want to talk about this so you'll know how to work on the algorithm, which in turn will help you with the coding. So let's talk about this. Allenton Water Department wants a program that calculates a customer's monthly water bill. The clerk will enter the current and previous meter readings. The program should calculate and display the number of gallons of water used and the total charge for the water. The charge for water is $7 per 1,000 gallons. However, there is a minimum charge of $16.67. And then it tells you, in other words, every customer is going to pay at least $16.67. So let's talk about this. Now on your screen, you can see I don't have the worksheet for the algorithm that you use. And that's okay. This just gives me more space on the screen. So you use the worksheet. I'm going to use this. So I'm reversing a few things because there might be some of you out there who think a little differently than the way I've had things laid out. So I'm just going to show you another way. First of all, according to your book, you should always identify the outputs of a problem first, and that is the goal of it. So the goal of this is to calculate and display the number of gallons of water used and the total charge for the water. So under outputs, remember outputs come to the screen. We're going to have gallons of water used, and we're going to have total charge for the water. Okay? Now, inputs is what can be entered by the user, and it specifically says the clerk will enter current meter readings and previous. Now, why is that? Well, because the way meters run is you have to have a starting point. So you would have where it ended last month, and then where it ended this month would tell you how many gallons of water have been used. Now this says processing item. So this time I'm going to give you a processing item or show you how to do one. Again, you can do this program without one, but for the sake of argument, let's just have one. So this would be we would call this gallons used. Okay? Well, we can't call it that because we have that up here. So let's take that back off. I won't do that one that way. Then let's call this, well, I'll tell you what. Let's leave that. We may end up not needing that at all. All right, let's go over here, and I've already put some boxes in, just saves me a little typing time working with you. So let's think about how this would work. So we know we have to have something entered, right? So we're going to have enter current meter reading and enter the previous. Okay, and that's so we can calculate the difference here. So let's come down here and let's call this, no, that is that. Never mind. Ignore me. Okay, we're good. We're good. All right. Then we know we have to calculate the charge, right? So we're going to calculate total charge. And that's going to equal current meter reading minus previous, right? I'll tell you what, let's not even do, I see what we can do. This will be easier. Let's do this. Let's do gallons of water used equals current meter reading minus previous. Okay, so that gives us our first output that we have to have, gallons of water used, right? But then we need to also calculate the total charge. So and that's where you would use gallons of water used that we just calculated, right? Divided by 1,000. Why? Because the cost is $7 per 1,000. So then we're going to do times 7. And that's going to give us the total charge for the water. Now, if that were all we were doing and we didn't have to consider a minimum charge, then what else would we have? Let me see if I can paste me another box. Yep, here he is. So if we would be done. Sorry guys, I don't want to, let me grab it. He's just wanting to just sit there listening to like all this. Come on, baby. Isn't that interesting? Of all days and times. Okay, how about we undo that? And it just wants to keep going back to the top, doesn't it? Well, I'll tell you what, let me get rid of it totally and do it again. Let me see if I can get it to come down here and do it. Of course not. Okay, but that time, let me grab it. Okay, so here we go. So at this point, if we had no decision making is being done, and we didn't have any decisions to make, at this point we would have display, right? We would show gallons of water, right? And we would have another display where we would show total charge. Okay? And we would basically sort of be finished, except we have a decision to make, right? So we have to decide if the client's paying enough, right? So right here, after we have calculated this total charge, we're actually going to have to come over here and ask a question. And this is my decision block, okay? Now, is the total charge less than, and they say 1667, right? So we're coming over here and we're going to say, is that correct? Is it less than 1667? Let's assume it is. Let's assume it's not. Let's go there first. Then we're simply displaying, right? So we would come down here and we're going to put no. I'm sorry. It's not going to. Sometimes when you use flow charting, it has trouble letting you write in line. Okay, no. Let me see if I can get it to put me up here and put yes. Okay, let's say it is less. Well, if it is less, we're going to need to do something about that, aren't we? And which means we need another little box. So what are we going to do? We're going to have to say, come on now, you're a misbehaving box. It's gotten behind. There we go. Let's see if I can get it out from under here. All right, let me get this box back over here that doesn't want to move. Here. So I can get it to move over here. Of course not. All right, that's the frustration sometimes of boxes. There we go. There we go. Okay. So what we're going to do over here says if the total charge is less than 16, right? Then the total charge has to be 1667. And then we'll come down and display again. All right, so let me give you a few lines in here just to make sure your thoughts are going like mine, okay? So we have a current meter reading that's entered, and sometimes these pop around too. And then we enter the previous meter reading. Then we're going to have a calculation, right? Or we're going to determine, goodness gracious, that's really got a messed up thing, doesn't it? Let me flip it. I don't know if you knew you could do that or not, but here we go. All right, so we are, we've got a current meter reading. We have a previous meter reading entered. We are now calculating the gallons of water I've used. Once we know that, we can determine the total charge for the water based on this formula, right? Total charge for water equal gallons of water used, and I don't know how this got gone, times 7, right, divided by 1,000, right? Gallons of water used times $7 per 1,000 gallons. Or you can do it reverse, it doesn't matter. Some people would prefer doing it this way, but because it's multiplication and division, any order works. So then you're going to say, is the total water less than 1667? Meaning, I'm sorry, is the total charge smaller than it should be, right? We're going to go this way, right? We're going to copy it over here. All right. And let's see if I can get yes in and no, right? Anyway, this should give you sort of the idea of what the flow chart might look like, right? It's painful watching me do this probably. Okay, so is the total charge for the water less than 1667? Yes, then the total charge becomes 16, and I had the wrong number, so it would be 67. Otherwise, it becomes no, and we display the gallons used in the total charge. So what's missing is one little line in here that I want you to see. And let me find it going. I want to get one going the correct way. That's why I'm going to take a minute here. Let's see if I can get it to go. Yes. So what I want you to see is it comes back into the same line. Okay? The only thing is we do have a decision in here. Now, once again, there are multiple ways that you can probably arrive at the same answer. And you see, I have not written out every little thing you are to do as far as C++ instructions. That's up to you. I can tell you, you'll use double numbers because gallons or meter readings might be partial. So I would use double for your variable names. You do want the money to come out pretty, so you're probably going to need to use a set precision. So set precision allows you to put the the decimal points after for money. So make sure you understand set precision. And then that's the basics of how that number 4 algorithm and then program would go. Let me know if you have any questions.